In this short video, I'm going to show you how to calculate the annual equivalent rate. This is a little different to the annual percentage rate. The annual equivalent rate applies to situations in which you make comparisons of bank accounts who are offering rates for a saving account. So checking around, if you look at a bank who seem to offer a similar rate of interest, you need to be aware of whether that interest rate is either what's referred to as a nominal rate or a real rate of interest. And it all depends on how many times you actually receive interest within that particular year. So say, for example, one bank could offer you 5% interest on your savings per year, and there's only one payment made out on that. But another bank could offer you a rate of 4.8%. However, this could be what's called compounded quarterly, which means you get 4 payments each year during that time period. So anything that has more than one repayment per year on an interest rate savings account, then you will have a real rate of interest that will always be higher than your nominal rate. So the nominal rate for the first bank was 5%, which was what we call compounded annually, which means it's just 5%. So the nominal is the same as the real because there's no more than one repayment on your savings for that particular year. And the other bank account has a rate of 4.8%, but that was compounded quarterly, which means your savings are rewarded 4 times a year on that rate of interest. Therefore, the nominal rate of 4.8% will be different to the real rate of interest, and that's something we have to calculate. And how you calculate that is through this formula called the annual equivalent rate. And in this one here, the R is their interest rate, N is the number of times the interest is paid throughout that year. Okay, so if it was annually, it's only paid out once, so the nominal is the same as the real rate or the AER. If it's paid out quarterly, it means that 4 will be placed in here instead of N, and that means that your interest is paid 4 times throughout the year. Okay, and the real rate of interest or the annual equivalent rate is the figure that we're more interested in. So don't be comparing nominal with nominal. So let's look at an example where a firm will deposit €60,000 with a bank at 8% compounded semi-annually. So the 8% here is known as your nominal rate, and what we want to find out is your real rate or your annual equivalent rate. And how we know that it's going to be different is because you see in that question compounded semi-annually. So we have to use the annual equivalent rate formula to get us this because you're talking about savings. Added to this question, we have a further part in which you're asked how much is saved after 4 years if there was no withdrawals being made. So this question is broken down into 2 parts. That first one is your annual equivalent rate, in which we want to find out the real rate of interest. And the second part is going back to your compound interest formula. So we'll worry about that when we come across it. So again, your annual equivalent rate, putting whatever we have in here, or is your 8% and N is 2, being semi-annually. Don't get confused with the number of years in the second part of this question where it has 4. Okay, so N in this case is to do with how many times it's compounded during that particular year. So semi-annually just means twice a year. Okay, plugging those values in, or of 0.08, N being 2, and both occasions they're divided by 2 and then to the power of 2. And we have 0.04, we're going to add that onto your 1, then get the power of 2 of that. Working through your formula, we end up with 1.0816 minus your 1. Don't forget that minus 1. Some people tend to drop it off when they're going through this question as a solution. And we have 0.0816 or 8.16%. So the initial nominal rate of 8% that was offered by the bank is actually returning you slightly higher rate on your savings because they're paying you twice a year on your savings, and you effectively get 8.16%. So that was your first part of that question. We wanted to find out the annual equivalent rate, even though we weren't directly specifically asked to do that, but we wanted to find out what the rate was. But the second part was that we want to find out how much is saved over that 4-year period if no withdrawals were being made. So they're receiving 8.16% per annum. And if they're leaving their money in the account for that 4-year period, well then The 8.1%, 8.16% is applied on your initial principal, which is your €60,000, and you will receive interest on interest. Okay, or in other words, you'll be earning interest on your reinvested interest. That we very similar to a previous video we just did. If you want to refer back to the video on simple and compound interest. So again, here we have these values, and now we can use the principal and n equals to 4 years in this second part. So notice the difference between the two ends. One is to do with the annual equivalent rate, where you see semi-annually, and the other one, n equals to 4 years, is to do with the compound interest formula. So recall the compound interest formula from the previous video, and we again just put in your values, P being your 60,000, your initial savings or deposit, or now is 8.16% or 0.0816. Do not use your initial nominal rate of interest of 8% here, because it's going to be different. You know, you're going to be receiving interest repayments twice a year, so we already covered that with the AER, and n to the power of n is your 4 years. Getting that 1.0816 to the power of 4 will give us the value 1.36857 times your principal of 60,000, and we will have an accrued amount of €82,114. So that initial deposit of €60,000 left in an account earning a rate of interest compounded semi-annually of 8.16% will accumulate or accrue to €82,114. It's always a good idea to compare two scenarios. This one with a bank account offering 8%, and I set another one up in which we have another bank where they're offering a lower nominal rate of interest of 7.6%. The firm or another firm is going to also deposit 60,000, and we're going to find out which bank offers the best rate of interest. So the first bank of 8% seems better than a 7.6%, but look here, we are now receiving interest that's compounded quarterly. Okay, in other words, 4 times a year, as opposed to the previous bank who was only giving it to us for twice a year or semi-annually. So it might seem more appealing to go with a bank that's offering us something or interest 4 times a year, but knows the lower nominal rate of interest of 7.6%. Again, the same applies after 4 years, how much is saved. Formula is also given in the exam if asked, and we just plug in your values, or 7.6%, make sure it's a decimal, 0.076. N here is your quarterly. Always use your quarterly, wherever it says compounded quarterly, compounded semi-annually, or daily, whatever it might be, always put in that value into your formula here. So again, just plotting everything in, 0.076 divided by your 4 will give us your 0.019. Add that, make sure you add that onto your 1, and then we get it to the power of 4. Once we have all that, make sure at the end you take your 1 away from your answer, which will give us a slightly higher number than your nominal rate of 7.6%. It's going to give us a rate of 7.819%. And you'll always should look and be aware that your answer here will be very similar to your nominal rate of interest. On both occasions, your first one was 8% and your AER was slightly higher. And in this case, you have a 7.6% and your AER is also slightly higher. So again, if you were to compare the two, this bank doesn't seem as appealing in terms of, or attractive in terms of depositing money with them compared to the other bank. But anyway, we need to complete the question, and we want to find out how much is saved if no withdrawals were made and you have reinvested earnings or reinvested interest, and you're going to, in other words, you're going to use your compound interest formula. Okay, this was your initial setup question. We already found what the AER was, and that was your 7.819%. So again, as a decimal, we need to express it as 0.07819. We add that onto your 1, get it to the power of 4, and multiply it by your €60,000, and we will have an accumulated or an accrued amount in your account of €81,085. And again, comparing the two, first bank offered you an AER of 8.16%, giving you €82,114, and the second bank, even though it had a lower nominal and more of a compounded or more time period in which you received interest, an AER of 7.819% still fell quite short of the other bank, and as a result of that you end up with over €1,000 less.